These are the notes for Chapter 14 on water. Please listen because I will say things that you need to take notes on that are not written down. You need to copy anything in red and turn this in to Mueller by Monday. I'll stamp it and give you your 150 points. That's Monday the 13th. All right, the water cycle. I know that seems pretty basic, but we're adding stuff to it that we didn't before. So one of them being volcanic steam. Again, that's steam, water vapor, but we're adding to it. Other one, sublimation and desublimation. Sublimation is when you have water going straight to gas, and desublimation is obviously the opposite. Evapotranspiration, that's evaporation off of any surface. Evaporation itself is off of water going into a gas. But evapotranspiration is water off of objects, off of trees, ground, anything like that. So you need to make sure you know the difference between those two. If you didn't, write it down. Evaporation is water going into gas state off of water. Evapotranspiration is water evaporating off of surfaces, any surface. Some of these are pretty basic. Snowmelt runoff, the runoff from snowmelt. Steam flow, gravity pushing the steam down. Fog, we're going to talk about how fog is formed later. A seepage is water going into the ground. A spring is water going straight from the watershed up. It can also be from the groundwater. Volcanic vents, they can bring the groundwater up. Infiltrations, water going down into the groundwater. Basically, the big things are the ones that I circled. All right, moving on. All right, water types. You need to make sure you write these down. Freshwater, saltwater, tap water, and bottled water. There is a difference between all of them. Freshwater, again, you don't only have to write down what's in the red. Water from the lakes, ponds, and streams made of H2O, water. There's sulfur, sodium, chloride, magnesium, and sulfates in it. Sodium being salt, NaCl. It's just a little bit, not too much. Salt water, you have a huge increase in that salt content. So it's made of water, salt. There's magnesium, sulfur, calcium, potassium, bromine, and carbon that usually comes from the volcanic vents. And the salt actually comes from the rocks and the volcanic vents. So the volcanoes and the types of rocks that are there are what makes oceans different from the ponds and the lakes and the streams. All right, tap water. We filter and add things to our tap water. So we take out a lot of the sulfates and the magnesiums and the chlorides, or we keep the chlorides and we add the fluorine. The fluorine is used to reduce tooth decay. It was shown that that actually helps, and a lot of other countries have followed suit from that. Sometimes there's metal ions depending on the area that you live in. And then bottled water. It's distilled H2O, so it has nothing but pure H2O, but it also has chemical contaminants from it being actually bottled and going through machinery. There's disinfectants in it to make sure that there's no bugs and germs. And there's actually, I spelled that wrong, but there's actually radioactive materials in it. Bottled water is technically worse for you because you don't have the reduction in tooth decay and because of the chemical contaminants that are in it. I suggest a lot of times that you just get a reusable container and fill it up with tap water, or you get one of those tap filters on there, but don't buy bottled water. That's basically what I'm saying. All right, if you're not finished, pause, and I'll move on. All right, groundwater. 3 different things. There's groundwater, the watershed, aquifers, and then the water table. Watershed is basically this area. You see it in dark green here. That is what the lake supplies the area with water, or the river, excuse me. So our watershed here is the St. Joe River. Groundwater seeps through the soil and becomes contained in the aquifer. So the aquifer itself is the rock and soil. The groundwater is the water that's in that aquifer, and that's where we can get our wells from. The wells have to go down into the aquifer to get the water, the groundwater that's there. If it doesn't go down far enough, it won't reach it. The water table is that point of when you hit the water. Sometimes it's 4 feet down, sometimes it's 6 feet down, sometimes it's 12 feet down, depending on where you live. That's why some areas don't have basements, because they'll hit the water table and you'll constantly have flooding. All right, if you're not finished, go ahead and pause now. All right, you don't have to write anything on this slide. I just wanted to talk about using surface water. This is what we use for our fresh water. It's surface water. We use the water basin here from the St. Joe River. I had looked that up. Granger actually uses the groundwater that's in that area. There are states that are running out of water and they have daily rules that they have to follow. Big hitters are New Mexico, Texas, Nevada, Utah, and some parts of California that are in the desert areas. Texas actually is spending government money to come up with water projects because they're running out of water so quickly. Granger's having water issues with their groundwater because it is contaminated, and we'll read an article about that a little later. But basically, if you live in Granger, I would suggest getting a testing kit, or when we do the water testing, bring in your tap water and we'll test it to see what kind of contaminants are in it. Usually it's a high level of nitrates, which comes from fertilizers. All right, tap water pollution. Oh, let's pause him for a second. All right, so our tap water can become polluted, like I said, with Granger. But there's also fracking, and I wanted to cover this. Say no to fracking. Fracking is when you fracture the water by a pressurized liquid. I'm reading this up here. This liquid is made of sand, water, chemicals. The liquid is shot through the ground, and it cracks open to get the natural gas that we need for energy. This process creates methane, which then leaks into the groundwater. And Jacob here is going to show us this. This was on Fox 28, I believe. They posted it on Facebook, and it kind of went viral. So I wanted to make sure you guys seen this. So he works in the oil fields out in North Dakota.
For tap water that we bathe in and just brush our teeth in. And it's pretty weird. Let me know what you think. See if it'll work.
So what that is methane. That's methane in the groundwater that's going through, and it's not being filtered at the plant, and then it's coming out of their tap water. So we could fix it by filtering it at the water plant, but the government denies that this is happening. Of course, kind of makes me angry. They say you can use the tap water, you just have to fill up your bathtub and let the methane leach out, and then you're fine to take a bath in it. But I'm not quite comfortable with that. It's methane, a gas that can kill us. So it doesn't seem right. They can easily filter it out at the water station. They just have to add another step to it. All right, water pollution, tagging on to that. There are types of water pollution, point source and non-point source. Point source is from a very specific location, a sewer, a pipe, somewhere where we can go, there's the pollution. This is the person causing it, like the BP oil spill. Non-point source, we don't really know where it came from. We just know that it's there. So like snow runoff that kind of goes through the streets and picks up salts and people's fertilizer and flushes it into the St. Joe River. The St. Joe River has a lot of non-point source pollution because people use too much fertilizer, or there's the salt from the roads. And this can actually be solved pretty easily if people plant the right plants and have the right rocks. If you're not done copying this, please press pause. All right, nutrient pollution. Yeah, there's only a couple of words you have to write down, just kind of put it together in a sentence. So nutrient pollution is excess of phosphorus that usually comes from fertilizers, and it causes algae blooms. Algae blooms decrease the amount of oxygen in the lake, and that can deplete plant life, other plant life that's there, and the fish that's there. So it can potentially kill a lake and turn it into a very nasty swamp. Toxic chemical pollution occurs when harmful chemicals are released into the waterways. This usually happens from industry trying to use the water as a cooling process and chemicals get leached into the waterway in one way or another. All right, there's sediment pollution. It occurs from erosion and is usually natural. This is where just sediment just builds up in the lake, like the lake back in Cooper Lab. That's sediment pollution. Thermal pollution is the one caused by the industrial plants. So the industrial plants cause two main types of pollution, a thermal pollution and a toxic chemical pollution. All right, moving on. The last one's the biological pollution. This is the main way that causes our health problems. This is when you have bacteria and different pathogens, different things that will help the E. coli grow more, fecal matter, things like that, that get into the waterway. And we use it for swimming or for any recreation purpose, and we end up getting sick by it. So it's usually not from our tap, but it's usually from recreational use. Groundwater pollution, this is like Granger, when you have the pollution leaches into the groundwater, and we use that for our taps. So again, we'll talk more about Granger probably on next Friday. Ocean water pollution. This is like oil pollution from the Exxon Valdez in Alaska. It happened a while ago. Or the BP oil spill that happened not too long ago. We will be watching a video on both. So make sure that you copy that sentence down. Moving on. All right, so the Clean Water Act, this is really important. It sets the water pollution standards. This tells us about point source, non-point source. It gives us rules to follow. Golf courses have to maintain this because if they use too much fertilizer, they'll actually go against the Clean Water Act. So it's become really strict rules on how our sewage system has to run, how we filter our water, how much fertilizer we can end up using. And believe it or not, most of us in our day-to-day lives go against the Clean Water Act, but it's really hard to try and find those people because if you don't use the right amount of water or of fertilizer to your grass, you'll actually pollute our groundwater and our water basin. All right, last thing is the water treatment. Drinking water has to be filtered first, and you can see here that there's really, it can be really, really simple when it's being filtered for our tap or in your own filter bottle. A lot of times they'll use sand and they'll use activated charcoal. There's also other ways that you can do it, which we will be doing a lab on a little later. So when you're doing a filtering process, this is only a 3-stage one. It can be very simple and not that complicated, yet we pay a lot of money for it. This is something that you can easily create on your own and something that you wouldn't necessarily need to pay all that money for when you could very easily do it in your own home. And there's videos on how to create your own water filter online. If you have any questions, please make sure you see me. Please make sure that you copy down these notes and show me on Monday. By Monday the 13th, I will stamp them and give you your points. Otherwise, you're missing those 150 homework points.